So welcome everyone to the web application performance tuning beyond JMX talk. And as you see, my name is Milen Dyankov, and I'm really hoping that this thing is going to work out and you're going to be happy with the talk. So let's try. So that is an important message to some of you. This talk is not about JVM and garbage collection tuning. So if your only reason to be here is to learn a few more JVM switches or tune G1 versus CMS or any other thing like that, that is not the right place to be. You may look for something that is more meaningful for you. We're going to be talking about web applications performance tuning, so we're going to be talking about performance tuning in general, not tuning the JVM itself. So I know what you're thinking. At that time, most people do that. Oh my God, this guy is just using the talk to advertise his own company, so he's going to give us all this marketing thing. No, that's not the case. I do work for Liferay. I do believe that's a great product, but I'm not going to be talking about Liferay during this talk. By the way, you may want to check the product. I think it's a great product. We are downstairs, so come visit us if you want to. We can talk about the product there. We're not going to talk about the product during that call. And why we are talking about the things that are not going to be in the call, as one more. I'll try my best not to do this in a way that this is kind of a university course where I'm the smartest guy that is going to teach you how to do things, because that's definitely not the way it is. What I'm trying to do here is share some experience with you, show you things that often has happened, and to kind of make you aware of what to look for, what not to look for, and things like that. So I do work for Liferay, as I said. My role there is consultant. So at Liferay, that means we do a lot of different things. Basically everything from training to solving customer issues to doing proof of concept, contributing to the core platform, a lot of things. And we have to deal with performance issues on more or less every stage, whatever we do. So performance tuning is one of the things that we do. And naturally, a lot of experience comes from being at customer side or working on projects. So this is what I'm trying to share here with you. And this is the time where a lot of people are going like, wow, that's great. Well, we have the performance tuning expert. Isn't that great? And the answer is yes, it isn't. Because I'm far from being a performance tuning expert, or at least I don't consider myself one. I have done a lot of performance tuning in my life, and there's still situations where I go and find myself that I still need to learn more, or I still encounter issues that I haven't before. So don't think of me as being the big expert. Again, it's just sharing experience. And this brings me to the other point, which is, do you really need the performance tuning expert position in whatever it's that you're doing in your company? Because a lot of people believe so. I'm honestly kind of confused whether that should be a role or not. I mean, can I name a person to be a performance guy? And isn't that just leading to like, okay, he's now responsible for performance, so we don't care. We do whatever we want, and he's going to optimize it. That's never going to work out. Let me refer to two talks that I've watched. One is, the bottom is called Don't Teach Developers Security. And it's a very interesting talk, you may go and watch it, but one of the key points there is that you can't expect regular developers to be a security expert. And the reason for that is their brains are trained to build things. In order to be a security expert, you have to think into breaking things, right? So the other talk is about debugging pretty much everything, and it uses this tool called strace. And it tells you that you don't have to really know the language or the technology that something is built with in order to figure out what's wrong with it. So what these two talks have in common, it is that in both cases, your developers or the people that work with the tool, with the application, need to have a common set of knowledge. They need to know the basis. They need to understand how things work. They don't need to be an expert. They don't need to be able to figure out every possible solution or problem that can occur. But they cannot completely ignore the fact that there are things like security and performance tuning and so forth. So you need to understand the basic, the foundation of like software industry and software in general. And so that is why often when we hire people, we actually try to ask them questions about performance tuning and things like that. And one question that I personally like to ask is stated like this. So you have this customer, and they basically tells you, the thing is slow, man. You need to improve the performance because it's really slow. So what is your reaction to that? So people typically answer like, well, we check the CPU and memory, or we check the database, or, well, we check the JVM params and garbage collection and, all kinds of stuff. And those are very good answers because basically what they tell you is what this person's experience is. Basically, they refer to what these guys have done in the past. But this is, in general, the wrong answer to the question which is put that way. It's, in fact, not a question, it's a statement. Right? So basically what you want to do is, instead, you want to ask them back to provide numbers to you, to provide units to you, and to provide their expectations. So basically asking them, what is slow for you? How do you measure slow? How do you know it's slow? And what do you mean by improve? And what do you mean by performance? And I think this is the key issue that we encounter when we go to try to fix things, is we speak different languages. We assume we understand each other, but we don't, because we mean different things. So the first thing to do is actually to establish a common language, a common understanding of what we are talking about, what is slow, what is fast, in what units we measure things, okay? So then we go one step further, and you typically have something like, well, let's go in more precise. We want to support any number of users, but our system only supports half of that or a lot less than that. And so this seems to be a defined statement, right? So we now know users, we know how many, that's great. So now consider this. Consider that N is a number of users that log in to your system at any time, right? It's be per month, per week, whatever your period is. Now consider the same N number of users that log into your system as a result of a marketing campaign, or because it's the Christmas is coming and your shop gets flooded, or because it is whatever it is. You just publish a ad in Google and everyone jumps in. That is the same N, but in a very short period of time. And those are completely two different things. Now, the third case may seem artificial to you, which is N users between N8 and N15, but that's a real case, believe it or not. What happened was a company had a corporate intranet. They had thousands of employees. And they set up the homepage of corporate internet to be the homepage of their browsers. So every single morning where every employee comes to work and turns on their computer, the homepage is loaded. So it turns out that you have thousands of users hitting your homepage every single day between 8 and 8:15. So the question is, should you optimize for that, right? And so here is another common confusion, which is confusing performance tuning with ability to scale. I'm not saying those two are completely different, because they are not, and they have a lot in common. But you need to be able to tell where the problem that you have is something that you need to solve by performance tuning, or something that you need to solve by letting your application being able to scale at the time where you need it, right? And the other thing about this is users, because user is something that is not really well defined. I mean, we know what user is, but what they do is not well defined. So a user can just see one page, or a user can take a whole lot different set of actions to do. So here is another thing. It's this graph that I kind of put together to give you an idea. So if you look at the scale from like more business to more technical terms and ambiguous versus unambiguous, the users are somewhere there. Right? So then you have different measurements like concurrent sessions, concurrent users, things like that. Then you have concurrent requests, and somewhere at the top, which is the most kind of defined thing, it's something like bytes, megabytes per second. And you as a technical guy probably want to deal with those, right? So you want to make sure that you can measure, because those are like, you know exactly what it is, 5 megabytes per second, right? The problem with that is your business partners don't really understand that. Those are not easily measured in conversions and sales and anything that they care about. So the goal here is to aim somewhere at the middle, something that makes sense for both parties. Because we don't program, we don't do stuff for our own sake because we are great programmers. We do this to solve business problems. We do this because the business needs some tools, right? Most of the time, right? So you need to find a ground in between where the things are somewhat well-defined and everyone understands them. Okay, so, but the challenge here is that the more technical you go, the higher is the risk that you're making the wrong design decisions. And trust me, we, as a Liferay, me personally, and me being part of other companies in the past, I've seen that all over again. We have made the wrong decisions. So let me just give you an idea of what I mean by wrong architectural decisions. So consider this statement. So you have an N that needs to move from town A to town B as fast as possible, right? So forget about programming in a second. In the real world, you would probably design something like that. So that's going to really make him go there fast, right? So what you didn't do is you didn't care to ask what exactly N mean in this case. So now you get your refinement, which says the N is actually a group of N people, right? So now you have already designed this, right? Eventually, it's already in production. So what you do? Well, you introduce M times the number of cars. That's not what you're going to do in real life, right? In real life, you'll probably change your design and go for something like that. But in a software, we try to think that, well, we designed that. This is already the way it is. So we now just need to tune it. Right? And sometimes performance tuning is just changing the design. And it's perfectly valid point. Performance tuning is perfectly valid point to change the design. That is basically what I'm trying to tell you here. So a lot of people then ask me, how do you do a performance tuning? And you know, anytime we do a talk, people think you're smart and they come and ask you for recipes. So kind of always telling him that it's like a drawing an owl. It's an old joke, you probably know it. So you first draw 2 ellipses, and then you draw the rest of the wall. Right, so that's basically how performance tuning works. Okay, but now you probably have enough analogies already. So let's try with an algorithm. That's something that's going to be more close to you. So if I were asked to put an algorithm in place about doing performance tuning, that's what I would do. I would say first define the units, define in what language we are exchanging information. Then define the expectations. What does it mean to be okay, right, when we stop tuning? And then measure, get your results. And as long as your results does not match your expectations, you basically look for the slowest component, find the bottleneck, remove the bottleneck, measure again, and go again and go again. So it's a very basic, simple algorithm that allows you to optimize your system. So if you look into that, it's quite right away obvious that the most important part here is measure performance. And so let's talk about measuring performance. So you have your application somewhere, and then you measure it. And you know, So how you measure it? Well, that's easy. We know that a bunch of tools out there that allows you to measure things. So whatever is your favorite, you grab it, you use it, you measure it, and you know. There is a little problem with that. And I think the problem is because we defined the algorithm in the wrong way. So let's go and look at the algorithm again. And let's replace measure performance. Let's split that into two steps. The first one we call collect data, and the second one analyze data. So now if you look into that in that perspective, what's the most important thing for you is collect data. So you don't focus on measuring anything, you're focusing on collecting data. So now this opens your eyes and it tells you, hey, there is a lot more data that I can collect. It's not just my application. So now you're looking at the full stack. You're looking at everything from end-user browser all the way through network, to application servers, JVM, your application, third-party tools, back through network to your browser. And there, in every single stage of that journey, there is data that can be collected and analyzed. And so now you have a lot more data to collect and a lot more tools for that, of course. And so in the process of that data collections, often a number of mistakes that show up. I'm just going to highlight a few. So that I think are most obvious, well, most often that happen, but you'll find all sorts of other things. So if you look at the browser side, the first thing that I find very often overlooked is the target audience. So people will just blindly create tests that does not simulate any audience. So we're going to hit this page millions of times and see what the result is. And no one actually asks the question, is that the real use case scenario? Will people really hit that page millions of times? Or we just say this page is irrelevant, not important, or we test something else. Okay. Which brings me to the next thing, which I often see, well, less and less, I have to admit, people have learned that, but I've seen that in the past, is people design a website, and what they do is they measure the homepage, right? Because everyone is supposed to go to the homepage, right? That's where we welcome our users. In reality, people very seldom go to the homepage. They go to Google, and Google directs them to some page that tends to be higher rated for whatever reason, because someone tweeted it millions of times. So, and of course, it happens to be that no one ever cared to test that page. So you just happen to hit the slowest spot. Another thing is, of course, JavaScript frameworks, overloading your stuff with all kinds of things like, analytics and things like that. You really don't want to do that. So going through the network layer, I think people tend to forget that network is actually a network. It is not a line, right? A lot of people tend to think about connection, that it's me here, it's the other guy there, and there's a line in between. If something goes wrong, well, that's probably somewhere in the line. In reality, you can go through different nodes. You can get redirected for rerouted for a variety of reasons. And if you don't know how that happens, whether that's external or internals, where exactly you may have a firewall or anything like that, you may be very surprised. One request can take you a second and the other one could take you 10 seconds. And unless you're 100% sure how your network works, it's something that you need to consider. Another thing that I often see that actually is keep forgetting that network actually works both ways. So I go to customer and they say, no, network's not an issue. Network's super fast. We just copied file from one server to another, and it's like blazingly fast. That's great. You just try to copy the same file backwards. It takes 3 minutes, right? So you need to understand the fact that it works fast one way does not necessarily mean it has to work fast the other way. So you need to test all your possible scenarios. And this is my favorite one, and that's the real story. At least it was taught to me as a real story, so I'll tell you it's a real story. So there is this company that is having issue with their database every Tuesday at noon. And they were digging with the problem for a long time, can't figure out what's going on. I check every possible thing that they could check. And nothing. It just every Tuesday at noon, database goes down. It took them a while to figure out, because they're thinking, what is Tuesday noon? What happens there? Well, the board has a meeting, but it has nothing to do with the application. So what could be the case? It turns out the board meeting was the case. There was this other director coming from the office across the sea, and it happens to be the way that the network wasn't configured in a way that whenever he plugs his laptop to the network, his laptop would steal database IP address. Things happen. All right, so on server level, I'm not going to talk about too much about those. One thing that it's kind of also happens, but I personally have done it a lot in the past, is to complain about something. So people choose to use this application server, and we all know it's slow. So why in the world we're going to go test that? We just keep telling them change the application server, or change the database, or change this, or change that. So my advice is, if you're doing this, quit doing it. It doesn't help. They're not going to change it. If the only reason they have it is they spend $1 million of that, that's a good reason. But what you can do instead is you can measure the thing, and you can provide them a result. Instead of telling them your app server is slow, you can actually measure this and give them the results. Oh, those are the metrics of your app server, and please do whatever you wish with those. So yeah, the other one is the virtual resources. We did have this case. We had a customer. Those numbers are fake, but we had exactly the same case. They just had like an order of magnitude more CPUs and RAM in their virtual machine than the physical one had. They were really wondering why it is so slow, because it was just switching context all the time. So there are a bunch of tools on the operating system level that allows you to collect data. So it's really no excuse for not collecting this data. Going through JVM stuff real quick. Of course, garbage collection, that. Collect garbage logs, things like that. Know what your threads are doing. It's very important. A lot of people don't do that, and they're like wondering later on what's going on. And keep in mind, that's also something that I see sometimes. People have, they are taught that they need to monitor everything, so they have their environments hooked with all kinds of tools that are constantly monitoring and saving data and things like that. That's great, but those tools also consume resources, right? As long as you do it right and it doesn't interrupt your work, then fine, but keep in mind, those tools consume resources. I actually, one of my first performance tuning experience was doing something like that. Start up everything I could have to monitor, and didn't even realize the system went swapping because of so many applications running there. So my results were, yeah, you don't want to know. Okay, so now we go to the container part. Yeah, again, the politics. The session part is one that I particularly want to mention, because I see developers doing this over and over again. As we build web applications, we need to store data somewhere, and it's the obvious choice. Where? In the session. Where we store that? In the session. Where we store in the session. And I really seen people ending up with sessions like 6 megabytes long. Keep that in. Imagine that. For each and every user, you have 6 megabytes of data stored in the session just in case he needs it. And then what people do, they cluster the thing and they turn on session replication. Okay, that's not a smart thing to do. So another thing is all these audits and all this stuff that works around. So we had a customer back in the old days with a previous company that wanted literally every click of their users to be recorded. So they needed to know, like you go to their site and click, and they needed to know the coordinates, like this user click here and this click there. You can do things like that, but you need to be aware of what the price for that is. Caching on application level is one thing that is often overlooked. Like, how many of you don't cache things at all? Oh, everyone is using cache. Great. Because if you don't, you just found your bottleneck, right? But on the other hand, I've seen misused caches a lot. And like we had this problem years ago. We were building a solution for Forex. And people, of course, were told that caches, need to cache, need to cache. And if you know Forex, you know that things change quite fast there. So basically, they were putting things in the cache every time something changes. And by the time anyone else had a chance to reuse the value from the cache, the value was already changed, so it expired, right? So basically, the application was doing nothing but updating the cache all the time, right? So yes, be careful about caches. They are useful, but you need to use them in the right way. Data serialization or transformation is another major slowdown. A lot of people these days will convince you that you need to go REST or web services or whatever, and that's super fast. Maybe, but serializing, converting from one thing to another, or even if it's string to integer and things like that, it takes time. And if you do it like once, it doesn't matter. But if you do it a million of times, it's going to slow down your system. That is the last one, which I see often, is some automated tools that are configured, keep a record of every method or every database call that lasts longer than 500 milliseconds. Sounds like a reasonable thing, right? The problem is, if you only have one call that lasts 5 seconds, it's nothing comparing to millions of calls that last 400 milliseconds, and it can be optimized. So it's not just about one thing being slow. You need to really understand how things work. It's not only the size, but also the amount. And so all these other things, like databases, external storages, third-party frameworks and things like that, you need to also be aware of how that thing works. You cannot simply assume that it's okay. I've been told millions of times, don't worry about our external system, it's fast enough. And then we go production and it turns out it's not. So you need to really be aware of that. And one final thing that is kind of covering everything that I told you so far, that is you really need, and most often than you think, another pair of eyes. It's really like if you find yourself in a situation where you kind of focus on a problem and then dig into it and don't know what's going on, you can do two things. First, go try to explain it to someone. It's very often just by explaining this to someone, the lights go on, oh, wait a minute, I know. Or just ask someone else to look at that. It's just, they coming with a clean mind, they will see it differently. So now you ask yourself probably, is it true? I mean, do I really have to do all this? Well, you better do. And I'll give you a bunch of reasons for that. The first is a famous quote from Richard Feynman. It says, it doesn't matter how beautiful your theory is, it doesn't matter how smart you are, if you cannot back it up with an experiment, you're wrong. I wouldn't put it that strict. I wouldn't say you're definitely wrong. I would say you cannot be sure you're right. And most likely, which means you're wrong. So there is another reason. You know this guy, right? And his famous saying. People tend to lie. And it's not because they want to lie most of the time. It's because someone lied to them. So every time you go and ask, how is this performing? What are the results of this? You have to take into account that they can give you a false information. Either because they did something wrong, they know they did, and they tried to cover, or because someone lied to them, or whatever else the reason is. Unless you collected data yourself, you never be 100% sure that you're analyzing the right data and you're getting the right results out of it. So another thing is we don't test things like that we think are great. Like, oh, this other great company and these great developers did this framework, so it's bug-free for sure, because those guys are way smarter than we are. Well, this picture is from the Louvre in France, the place where it's all about beauty and everything. And my last idea was that I'll find something like that there. So yeah, even the big guys sometimes take a shortcut. And finally, the usual suspect. That is common thing. That is the first side that I show you, people that say, oh, I'll check JVM, oh, I'll check database. That is because we've been there so many times. I've done so many projects, and every time was the freaking database. So I know that it's the database fault. So I go there and I'll fix the database. So don't. It leads to, it may be, but it may not. Okay, so the thing after that, after you collect all this data, what you do with it? You analyze it. Who is going to, well, while there are many tools to help you collect data, and in fact, everything that I showed you in previous screens can be automated to a high extent, that all this data is automatically collected for you and you don't have to do a single thing. While that is the case for collecting, now you're the analyzer. You're the one who has to look into the data and analyze what is there. And the problem with that is you're a human. Why is that a problem? Because as humans, we have great powers, but also we have great, how to call it, not limitations, but kind of problems. Imagine that's an elevator. You're approaching that, well, not you. You're smart guys. You're at the conference. You know I'm doing tricky things with you here, so not you. But an average person is approaching that elevator, and they have these 3 buttons next to it. So how do you think? Which button an average person would press? Taking bets? Right, they're going to press 2. Now imagine that they press 2 and doesn't work, nothing happens. What do you think they will do? I bet they're going to press 2 one more time. The first thing that they come to their mind would be, oh, I probably didn't push hard enough. Or my finger slipped or something. They try several times before they go to push any other button. You know, want to know why is that? It's called the base rate fallacy. It basically means that when people are given information that is very specific and very broad, they tend to focus on a very specific information and tend to disregard the base rate. So mathematically speaking, you have 3 buttons. The probability of one being the right one is absolutely the same for each button. Like, if they weren't in different colors and shapes, what you would do is probably press all 3 of them, because your brain would just take the math. But because they're in different colors and shapes, your brain is playing game on you and saying, oh, these 2 colors match, so this is a higher chance this one is the right one, right? And it's so convinced to do that, that goes to the next thing, which is what we do. We try to test a hypothesis which we think is the right one, ignoring all the other hypotheses. And that's what we're doing performance testing. We focus ourselves on something and say, it has to be this thing. And now I'm spending 3 days trying to prove that this thing is wrong, right? We don't test what if it's not, what if it's something else, right? Because we're so convinced that this is the thing that is to be fixed, right? So be aware of that. I mean, I still do it, so you will probably do it for some time. So get back to the algorithm, and the next thing we kind of look at it, well, the last one is the remove thing, the remove bottleneck. And I'm really sorry to not have any definitive solution for that. Come on, works. But I'll give you some tips. What is it? Oh, I guess my batteries are dying. Okay, so this is from another presentation from Martin Thompson, and he's doing a great talk about performance tuning in general, and all this, crazy stuff, Java, tweaking things. But one thing he mentions there is that he goes sometimes to a client and gets the 3 times improvements, performance improvements, just by tweaking the virtual machines and the operating system. And that is the message. Step out of your comfort zone. If you're a Java developer, what you focus on, what your comfort zone is probably Java, a few more frameworks around Java, whatever it is, that's where you feel comfortable. That's what you do. And all the rest is none of your business, right? What you do in performance tuning probably in this case is you just say, it's not my problem. My application is fine. You go find yourself a DB specialist or whatever, operating system specialist or whatever. And that is the wrong thing to do. for the reason that they will not trust you. They will think that you are just playing around, you don't want to do things. You're not supposed to be able to fix every issue on every layer, but you're supposed to have the basic knowledge of how things work, a basic knowledge of how to measure things. So you can tell them, listen, here is the performance benchmark, the metrics, whatever I have for the database, for the operating system, for network, for something else, which clearly indicates you guys have an issue with that. It's not me telling you it's not my problem. I'm just pointing you to the problem. Now I don't really know how to solve that problem. You go find the expert to solve the problem for you. Right? But you need to kind of do this additional step out of your comfort zone to be more convincing. You've seen that? That's one of my favorite. So this is basically what happens when you go on the internet and find a JVM or whatever tuning parameters and blindly copy them to your application. Right? I keep showing this to people. People still do that. Don't. You need to understand what you're doing. If you see that long JVM parameter string, before you copy paste it to your production environment especially, you make sure you understand what all these parameters mean. All right? So another thing is on the application level, and this is more to kind of where you are. So I already mentioned the cache. One thing that I surprisingly find people not knowing is what is the difference between blocking and non-blocking cache? If you don't, please go find out. It's important. The other thing is data structures. So back in the old days when I was interviewing people and some of my colleagues were interviewing people, we often had this, like, the difference between array list and linked list. And we hired this guy, who's a real smart guy. He's like, are you guys crazy? I mean, what kind of question is that? In fact, that's a good question. It's not about whether you know how those two are implemented in Java or any other language, but did you care to learn what is the data structure behind those two? Right? Because if you don't know what is a data structure behind a list, how do you know how the list behaves? How do you know how to scale the thing? Right? You don't. You're purely guessing. How do you know when to use one or another? Right? It's the same thing with method complexity. A lot of people will just use a method that is there. I had this guy on recruiting, ask him, can you write me down any sorting algorithm that you know? And he did collections.sort. Fine. That's the only thing he knew. It's just there is a method and give an API that does this. So you need to understand what a method does. What is its complexity, like how string builder, string buffer, concat, and things like that are implemented in terms of what their performance is in any given scenario. And of course, logging. I'm not going to even talk about that, but you don't want to know how many debug time CPU time is wasted on debug statements. Okay, so if all that doesn't work, what you can do? Well, you have still a bunch of options. You can go multi-thread, you can go asynchronous, modular, multi-VM, off-heap. All those are valid, and all those I consider a performance tuning steps. And as I mentioned earlier in some slides, sometimes a performance tuning is changing the architecture, and don't be afraid of that. If being faster and being more productive means you have to change the way you work, well, you probably change the way you work. You're not saying, I'm going to always work this way, I'm just trying to make it faster. Okay, hope this makes sense for you. Probably for some does, but some are going like this now. Say, wait a minute, I'm developing an API or a library or something that is for generic use. I have no clue how people will use my thing. Well, welcome to the club. We are in the business of creating a portal, which we give to people, and they do all these crazy things we never thought they would. So I have few things to tell you about that. The first and more important thing is don't assume anything. You especially don't assume how your users will use your product, because they'll find millions of ways you never thought of to use your product. And then when they use it in that way, they'll complain, it's slow, it doesn't work right, and so forth. So what is the thing that you could do is make it configurable. In Liferay 6.2, which is the latest version that is out there, we have 2,382 properties. Now, of course, some of you will argue that not all of those are performance tuning related, and they are not. But a lot of those are also count into performance tuning. Like, for example, we allow you to change storages. So you can use a file system storage, database storage, or whatever else storage you want to have. And it's not because we just had nothing else to do, and so we decided that's going to create a bunch of storages. It is exactly for that reason, because you're going to be using this portal in many different scenarios, and there's no way for us to know what scenario is going to fit your need, what scenario is going to be most performant in your particular case. Same thing is with workflows, with everything. So whenever you are able to modularize things, to split into small components, to make things configurable, you should do so, because this will allow your customers to configure your product in the optimal way for their particular use case. You should never assume you have to use it the way we design it, because they will not, most likely. Another thing that we're doing with the next version is we are changing the whole thing. We're going fully OSGI, with the bundles and stuff, and the whole deployable small pieces. And that's performance and easy of use. That is one of the problems that this approach solves, because then you can remove all the components that you don't need, right? You can replace a component with a more performant one, and so forth. So think of it, it is not just it's not just you that decides how people will use your thing. You have to give them the options. So when you give them the options, you make sure you document those. So in our configuration file currently, we have whatever 6,000 lines that documents it, and that's, I always argue that it's not enough. Right? We should put more documentation there, because people should understand not only what switching this from A to B means, but also what is the impact on other things, how it impacts, security, performance, whatever it impacts. Right? So we're constantly improving the documentation, but you need to have a documentation in place. That is crucial. If you are configurable, you need to explain to people how to configure things. Okay. The third thing, which is not less important, is to provide a reasonable defaults. So we have this zip filter in the platform, that's what zip filter do, zip content. And the reason we have it is because we want the people to experience a fast portal from the moment they start it first time. But if you go production and you have an Apache or any HTTP server in front of Liferay, basically your Apache is going to do a much greater job than the zip filter. So what you should do is you disable this and you turn zipping on your Apache server. So you provide a reasonable defaults, but also let people do whatever they need to do. And the third thing, the last thing actually, is try to provide a performance results for a typical use case scenario, because people will gonna go and ask you for that. So how fast is your product? And what your answer would be, it depends. And that's gonna be a true answer, but they gonna need to have a baseline to compare to, right? So in our cases, we have this thing called performance white paper, which basically states, those are the 3, 5, 4, whatever use case scenarios that we tested. And we can tell you that in those cases, it performs that way. So it gives you the baseline. So if you go do your own custom thing, well, that's probably going to be not exactly the same, but at least you have a baseline to compare to. Oh my God. That's pretty much everything I have for you guys today. it is, I guess, time for questions. Don't see if you are up there and have a question, just shout, because I don't see you. No questions? All right, thank you then. Thank you.